Good morning, everyone. Let me just minimize everything. How could I do that? Because I have just installed an external monitor. Yeah. Display. Okay, display. All right, done. Okay. Wow, very cool. I got the other monitor working already. Okay, let me just share. Desktop 1 or desktop 2? Desktop 1. Allow. Open. Yes, of course. Okay, I'm back again. I have to restart so that everything's going to work smoothly. So it's recording, correct? Still recording. All right.
Yes, sir.
So how was your long vacation? We don't have any class last time. How was everybody doing? Have you tried to explore
Spread with a lot of
the
error.
the activity that we have last time? Cluster. Okay. Explored with a lot of errors. That's okay. Everybody got a lot of errors at the first time they tried to explore everything, because you just have to, put your other feet on the water. I mean, you need to dive and then feel the experience. But there's no gonna be wrong answers in this one. You just really need to explore. But I believe some of you already had some answers. Actually, you know what? Debugging is a skill that we really need to experience. That is the only way for us to gauge if we are uh, gaining knowledge of what we are doing, especially in data science with Python. This is like a programming subject with the flavor of data science. It's not actually just programming, but with data science. Chat GPT helps. I advise you as beginners to really go with Chat GPT, but make sure you will try to do it or experience it typing by yourself and then really digesting every line of code. I remember before when I was learning Python, it's not an easy road to learn Python. I started way back 2007. Maybe you some of you will be shocked. Oo, kami nagsimula lang ngayon. Si Sir pala 2007 pa lang nagpa-Python na. I was a very beginner programmer way back 2007. And my pre-loved programming language actually is C and Java. Then uh, Python became popular again starting 2014, but still not being used as a general purpose programming language, just for scientific purposes only, or just by learning logic. Then data science came or data analysis came, and Python became the most famous programming language starting 2016. So I got back again with Python and then reviewed it with some new knowledge with data science. I started actually today, I'll show you some tools that are being used in data science before when there was no Python yet. We are actually using some tools. We really did not start with Python. That's why all I can say that data science learning with Python is a really advanced subject. I also had a short interview with other colleagues of mine. Then I asked them, how can you rate the difficulty of learning Python at the same time learning data science as a beginner? All of them said it's an advanced course, and some of them said the prerequisite is actually basic knowledge with Python, but not necessarily super advanced, just the basic knowledge or just basic knowledge with what is programming per se. Because before, data science is a separate subject, and data science is being practiced with tools such as Weka, a Rapid Miner, MATLAB. MATLAB before was like the Python nowadays. So before it's MATLAB, if you're going to talk about data science, the programming language go-to is MATLAB. Then everybody shifted to Python because MATLAB is a proprietary software, meaning you need to buy the whole software in order for you to experience data manipulation and data science. So comparing that with Python, Python is a free programming, open source programming language. Many shifted from MATLAB to Python, and then basically the coding process is not as tedious as C and Java, and many scientists liked it because they don't really wanted to code a lot of they don't want to really code a lot. So that's the reason why. And people who started with MATLAB also don't want to code a lot because in MATLAB you can also code shorter compared to Java or to C. So that's the history, by the way. So if you are struggling nowadays, it's okay. It doesn't mean when you learn something from this 10 session data science, it doesn't mean you're going to be an expert already. It is it is the advent of your learning with data science. It doesn't stop here. Learning data science is something that you should be um, invested into. Like you start learning bits of pieces of knowledge today and then move forward. Uh, Go and look for more sessions. Doesn't mean that you really need to enroll again to this course. You can enroll with Coursera. Some of my supplemental knowledge came from Coursera and Udemy. Not everything is, and sometimes in YouTube. Not everything is on a boot camp, something like this. Sometimes learning from boot camps makes you fuel your passion with regards to data science. If you are interested in data science, yes, it's good to enroll first in a boot camp, and then from there you can iterate your knowledge by exploring more, immersing yourself more. If you learning data science or data analytics is something that you should practice every day. That's why um, learning data science is learning data per se should be a part of your work. If you're working right now and you're doing some task with regards to data, that's better because it is not going to let you go away with your knowledge in data science. For me, I was a teacher for almost 14 years. And the reason I easily got into data, first, the very initial data set that I have encountered is students' grade. I have to cluster my student based on their performance. Let's say I have very good performing students. I have medium or average performing students. And then I have some students that are not very well good, or they are can be considered poor performing students. So it is important that you convert those poor performing students to at least average and do not let them stay that way. So that's the first data set that I have encountered and always being encountered as a teacher. Well, if you are working in the industry, maybe there is something there that is related to data. Can you provide uh, some kind of data related work you are doing every day from your from usual everyday work? Can you type on the chat box, everyone? Hello. Any data related? For me, since I work closely with the Senate and HOR, we tend to have a lot of data. How many data? Is it 11 gigabytes of data per day? Well, right now, if we were talking about uh, really big data, it should be 11 gigabytes of data per day. And that's a different problem. I work in the laboratory, so we gather experiment results. Vulnerability report from scanning tools of different servers. Okay. Vulnerability report. I also like the credit card data fraud analytics. Okay. So let me share the part of session 5 where we will be talking about some theoretical stuff. Can you see it? For me, small data lang siguro. Traffic survey data. You can say that your data is small if it's just megabytes, around around 20 MB, just small data. If we're talking about big data, you're talking about gigabyte, starting with gigabytes of data. And that's a different story. So I suggest if you want to manipulate really big data, there is no yet course I can see in the academe that caters really big data. I only see some specialized training, especially uh, industry is the one giving that training. I do not see any school yet providing that kind of training. The training that you are going to manipulate 11 gigabytes of data or probably millions of data, because um, there is actually a different story if you're talking about millions of data versus just hundreds of thousands. Let's say less than 100,000 data or instances. There's actually a different story. Extracting data from vessel daily, noon report, then arrange and sort in Excel to visualize on the dashboard to know if the vessel engine is working, especially fuel consumption. Um, you know what? Excel can only handle 1 to 2 million data and it will crash. Or sometimes less than a million. Have you experienced your Excel crashing or slowing down? If
Yes,
that's
sir.
the case, if that's the case, you are working with data close to, but not so close to big data. It's just close to, kasi I have experienced hundred of thousands of data lang of instances, naghahang na yung ano ko eh. Yung Excel ko eh. So, sa totoo lang no, just to break the bubble. Ang pinakamalaking data talaga, very complex na siyang i-handle. Gumagamit na siya ng concept ng Spark, gumagamit na siya ng concept ng batch processing kasi so sobrang hindi mo na siya ma-load in one go. Yeah, but sometimes it can go to around million. That's the promise of Excel. We are just around million and then we really crash. MS Access, depende. You know what? If I'm a technologist, I'm not going to suggest to use Access. I would suggest to use SQL, but I would shy away with Access. Kasi Access is hindi na siya na-update. Sobrang tagal na siyang hindi na-update. Sobrang naiwanan na siya ng technology. Nagagamit siya sa small problems kasi madali siyang i-program. Pero other than that, pagka biglang laki na ng business, wala akong narinig na sobrang laking enterprise na nag-rely sa Access. Hindi na siya ganun ka-reliable. So people are using relational databases or SQL. So do you see the module 0421 should be 29. Should not be 29. Should not be 21. Should be 29. What happened there? Di ko ma-edit. Ayan. So there are different kinds of analytics. If we're talking about analytics, let me just check if we're viewing the same page. Yeah, we're viewing the same page. So if we're talking about analytics, saan yung ginagawa natin sa data science natin ngayon? Dito pa lang tayo sa descriptive analytics. Most people that are advanced in data science can perform diagnostic analytics and prescriptive analytics. But today we will tackle predictive analytics. So we will try to have, this is what we are doing for the past 4 meetings that we had. We were doing descriptive analytics. What is the components of a descriptive analytics approach? We are exploring the data, we are visualizing the data, and try telling stories or insights with regards to our data. So that is descriptive analytics. This is just answering the question, what happened and how many, and try to discuss what is the meaning of the data. So this is descriptive analytics. So in predictive analytics that we will try to do later, it's trying to answer the question, what is likely to happen and what will happen if we take this action. Or sometimes it provides us a forecast of the future from our data. So this is the reason why data science provides value to the company, because it can actually forecast, it can add information coming from the data. We can call this one data mining. So when we do descriptive analytics and predictive analytics, we mine the data. What does it mean when we mine the data? We get more information with our data. Okay? Because every company is like battling. We are having in a company, we are facing a war. It's not actually a war. It's like parallelism to a war, where you're trying to understand your enemy. And in order for you to understand your enemy, you need to gain experience. And that experience can be harnessed from data itself. So we can actually get information from our data. Okay, so right now, I want, does any one of you try to wanting to show the results from our last time activity? There is no actually a right or wrong answer. I will not say that if your answer is wrong. Okay. Saan na pala yun? Saan ko nilagay yun? Sa session 4 ko ba? Ito, sa session 4 ko pala nilagay. Okay. So I have here some ideas. Perform analysis. You could analyze the performance of the teams by looking the error rate. Have you tried to analyze there on the BPO dataset who are the performing teams? Can anybody show me any insights for the performing team? Hello? Hello? Narinig ba ako? Hello? Okay, so meron ba? Show lang muna. Meron bang gustong mag-show ng insights nila? Curious lang ako kung merong nagkumuha ng ng performance ng teams. Okay, so this is a result. Teka lang yung computer ko kasi Mac ngayon. Medyo what screen are you looking at? Teka lang. Mali. Dito dapat. Wow. Error rate. I like this pie chart, by the way. Satisfied customers per team. So the team of Bucky Barnes, 36.3%. Joey Hordison, 31.8. Do you know what? I have an interesting story with regards to this. Let me just, paano ba ito yung preview ko? Teka lang, stop share muna ako. Hindi ko siya maano eh. Ayan. I have an interesting story with regards to this pie chart, and I hope every one of you could gain knowledge from this one. Look at this one. If we try to remove this percentage or this percentage, if we try to remove all of this, we will have a very difficult time to know the actual size of these two portions kay Joey Hordison at kay Don DeMarco. Kaso this is the limitation of Python. If I'm going to do this in Excel, I might be using a donut chart rather than a pie chart. Buti na lang, ang ginawa dito sa pie chart na to is nagkaroon ng emphasis on Bucky Barnes kasi ni-left yung portion ng pie. Tsaka nilagyan ng data labels. So, na-focus yung mata ko to understand, parehas lang pala ng laki yung kay Joey Hordison tsaka kay Don DeMarco. Pero kung walang data labels yan, I will be having a hard time understanding sino yung mas malaki, sino yung mas maliit. No? I like this one. I like this pie chart. Bakit ko nagustuhan tong pie chart? Kasi in 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 ano ba to? Ano ba to? Quick glance. In my quick glance, I could easily understand that Bucky Barnes won the satisfaction from the customers. Their team. Marvel team siguro to. Bucky Barnes eh. Ayan. So, yun yung ano essence ng visualization, by the way. Dapat isang tingin naiintindihan ka agad yung report natin. Ayan. So tingnan din natin yung iba. Okay? Ito, yes in error rates. Ang pinapakita nito sa akin probably is a scattered organization of yes in error rates. Yung mga errors na na-encounter ng bawat team. So, the level of intuition when I see this chart is on the middle. To be honest, on the middle because I really need to have experience looking at visualizations for me to appreciate the result. If it is me going to visualize this one, I would try to, instead of scatter plot, I would try to use a simple bar chart at first. Okay, or a simple column chart. But more or less, this is going to be an advanced approach to visualizing the data because it utilizes scatter plot. Kudos for that. Right? I am particularly interested with the visualization. Okay. So this one is a visualization of the error heat map by team and shift. Okay. It looks to me that more errors were omitted by Bucky Barnes. Is that correct? Yun ba ang ibig sabihin nito? Or mas yes. So mas maraming error ang na-omit nila Bucky Barnes. Okay. Okay. I like this one, no? Okay. So meron siyang mid-shift to nasa baba. May mid-shift, may PM and AM. I like this analysis. So sa PM mas maraming error, no? And across all three teams. Ay not particularly pala. Mababa sa ibang teams. Kaila Bucky Barnes lang yung mataas. Parang ano to, no? Why? Alam nyo, pwede nyo pang i-dig deeper to yung visualization na to. Pwede nyo pa tong sabihin, probably yung team ni Don DeMarco, mga not tenured. Trinay nyo bang mag-drill down bakit sila Don DeMarco at saka Joey Hordison, konti yung errors nila sa gabi? Yung mga agents ba dun sa gabi na yun, mga tenured? Ako ang speculations ko kasi kapag tenured, tumatamad or naglulus yung productivity. Kasi syempre tenured na ako medyo complacent na ako sa trabaho ko. Konting trabaho lang. Ganun yung mga tenured, di ba? Kadalasan. But that not necessarily everyone. I'm interested with that. Sige, tingnan ko yan later. Ito, I love your exploration with the data. this is a very simple approach. So this is yes. Okay, the result was yes. Ano nga ulit yung context ng CSAT? Is that a approval? So, is that an approval? Yeah, an approval. Satisfied customers. Satisfied customers were good around AM and PM. Ito, meron tong drill down. Pwede nyo i-drill down yung information na to. 'Di ba AM, PM, mid. May tinatawag kasi kaming bias dito. So, possibly kasi mas maraming ano sa AM at saka PM. Mas maraming tao sa AM at sa PM kaysa sa mid shift. Kaya, yung satisfaction mababa sa mid shift. Another story or another hypothesis. Talagang magagaling yung empleyado sa AM at saka sa PM shift. Tapos yung mga empleyado dito sa mid shift, medyo patamad-tamad. Kasi siguro yung mid shift, ano yan eh. Ano na siya eh. Hindi ganun ano. May mga tao kasi na morning person tsaka evening person. Itong mid shift, kadalasan hindi yan ano eh. Walang taong ganyan, di ba? Kaya yung mid shift yan yung mga broken sked. Kaya yung performance nila dyan, nakakatamad. Ganun, hindi sila motivated or hindi sila fresh to work yung mid shift. It's either you are a morning person or you are an evening person. But more or less, so those are the two sides of the coin or the hypothesis that we can gather from this information. And then what else? This one. Okay. Error rate heat map by team and tenure. Ayan, I like this one. And I like the naming convention of this result. Okay? This provides a clear context. Okay, ang comment ko lang dito, yung number sa baba. Yung number sa baba, it's better if you're going to make it in a vertical position. So, talagang yung grupo ni Bucky Barnes and ano yung ibig sabihin ng 7? 7 years yung tenure? Seven years. Okay. So, there is a correlation with the performance of the first years and the 7th years. We really don't know what's the reason why, but it's a good hint that in our theory, if you are the cost of your performance, maybe you're just a beginner for the first year, then you are slightly getting a hang of it when you are on your second year. On your third year, maybe you're feeling some laziness, a little bit laziness. Around 4 years, you are stable on your performance in your 5th and 6th. Then on your 7th year, most of you are having worse error rates. Then, maybe sa 7th year, dyan na rin nagre-resign yung iba. Pagdating ng 7th year, nagre-resign na sila sa work or tinatamad na sila, then yung mga 8 years siguro they feel the urge to do or they felt like they wanted to, make their work better again. And then on the 9th, stable, and the 10th. Okay, so this breaks our idea that many of the employees here will be slacking when you reach the tenured ship. Pero ang makikita ko lang dito is that may problema talaga kay Bucky Barnes kasi yung team naman ni Don Marco tsaka ni Joey Georgeson okay naman. So hindi tenure ang problema dito. Mas marami lang dito kay Bucky Barnes problema. Okay. Very good analysis. Mag-add ako ng analysis siguro by next meeting with this dataset. No. Meron pa ito. Error rate per age bracket. I like this one. Error rate by. So this is from Bianca. So hindi ko nabanggit yung mga nag-participate. So thank you Bianca again. Eileen, yung kay Eileen table, no? Okay. Reggie, thank you. Ayan. Nico, Jacqueline, very good. Ito yung kay Bianca, okay. Ayun o, pie chart. Yun lang talaga problema sa pie chart, no? Kapag walang label, hindi mo alam kung sino yung mas malaki. yun yung reason kung bakit yung pie chart hindi masyado nang ginagamit sa industry. Pero yun yung limitation ng ano natin nung code natin Hindi tayo makapag-donut chart dito or probably pwede pero sa ngayon hindi pa tayo makapag-donut chart. Pero I'm not saying this is wrong. It's just that I want you to be aware that some parts of the industry, they shy away using pie chart because of the reason that it's hard to initially get the intuition which ones are the biggest when it comes to the proportion. But in analyzing this one, so we have error rate per age bracket. So the error rate starts around so the biggest error rate came from the 40-year-old employees. Okay. Okay. If you come up with this result, by the way, if yung result natin is medyo sensitive, error rate, meron tayo ditong ethics, by the way, no? Pag error rate ang pinag-uusapan natin, tapos tatamaan dito yung mga empleyado, magkaroon tayo ng drill down. We should not pinpoint immediately na kayo mga 20 na mga 40-year-old, kayo yung mga problematic, ganon. We should not do that. Maybe there was just an instance that some of the 40-year-olds had bigger error rates than the younger ones. Kasi bakit ko nasabi yun? Yung mga 50-year-olds naman, okay lang sila pero kasi ganito yan. Kaya naman 18% lang yung error rate ng mga 50-year-olds. Kasi baka naman konti lang yung mga 50-year-olds sa company. Tapos baka yung mga 50-year-old is iba yung simple na lang yung ginagawa nila. So ganun siya, no? So ganun siya, no? Ang tawag dito. Magdi-drill down tayo. Yes, that's okay also. yung explode function para ma-emphasize. Although some ano talaga, some parts of the industry, lalo na yung story IQ, yung school ng story IQ, they will really say that pie charts are not a good visualization tool. May mga ganong agency, yung story IQ. I'm just saying na may mga ganon But it doesn't matter kung yung mga nasa company, wala silang they don't care about that. Okay lang kahit basta importante ma-report and ma-provide ng documentation, okay na. Siguro depende na lang yan sa perception ng iba. Siguro yun yung mina-market ng story IQ. Story IQ is a learning agents, ano ba tawag dito? Basta prestigious yun eh. They are a prestigious learning school with regards to data storytelling. So, yun yung nila, pinupush nila. Okay. Okay, how about this one? Ano kaya itong mga nasa taas na to? They are error rates of everybody. And yung mga 60-year-older, baka kasi konti na lang yung 60-year-older, kaya ganun. So, let's observe the colors. Blue, green, red. So, tatlong color siya.
Sir, hindi ko nalagyan ng label sa mismong graph niya pero nilagay ko sa chat yung color coding or label.
That's an interesting insight.
I think for this one, sir,
Na si Bucky Barnes is an outlier.
sir,
Before I was reading a documentation of a data science article, kahit madami yung result, since in a spectrum of grouping, katulad na nangyari dito sa dataset ng mga call centers sa BPO, no? Si Bucky Barnes pwede siyang maging outlier or pwede siyang i-remove as outlier kasi yung dalawang team naman performing good. So if we're going to scale that in 3 portions, 70% of the company is performing good. Kasi sila Bucky Barnes lang ang may problema. So kung magiging okay sila Bucky Barnes, kung hindi maging okay sila Bucky Barnes, pasado pa rin tayo kasi 70% pa rin yung acceptability ng performance ng company. So yes, that's an interesting insight, no? Yung kala Bucky Barnes are outliers. Nagiging interesting na yung data science pag nandito na tayo sa visualization and we are transcending from simple coding. Kasi yung simple coding is medyo boring kasi nakaharap tayo at nagko-code. Pero pag may visualization na, tapos nagpo-provide na tayo ng kwento, we are now harnessing what we call the term data mining. We are now data mining by means of descriptive analytics, no? We are mining information from our data. Yan yung ibig sabihin ng tinatawag nating data mining. We are mining the data. By what framework? By means of descriptive analytics. We are mining the data with respect to descriptive analytics, or sometimes we are calling this one EDA, or exploratory data analysis. Okay, so nade-data mining na natin siya. Yun yung mga unang mga tawag sa data science eh. And then nag-evolve siya. Dati nung nag-i-start ako ng data science, ang tawag namin dito sa data science is data mining. Tapos yung iba ang tawag data analytics. So unti-unti nagfa-funnel na yung knowledge, nagiging mas correct na yung term. So pinaloob siya sa isang concept called data science. Because it is the science of data that we are manipulating. Kaya siya tinawag na data science. So, data science is data mining by use of an analytics. But what kind of analytics we're talking about? We're talking about descriptive analytics. So data science, data mining, analytics, descriptive analytics. So pag mas pinalalim pa natin yung descriptive analytics, pupunta na tayo sa mga tools. So Python, Excel, Power BI. Yan. Now, before we move forward to our next topic, sige, mag-next topic na tayo. It's time check, it's 10:31. Let's have a short break of 30 minutes. 30 minutes, so we go back around 11. Okay, is that okay? Then our topic for today is clustering. I will teach you clustering. Now magka-clustering tayo. Okay, so we will pause for 30 minutes. Nga pala, no, yung mga nag-solve nung activity last time, pwede nyo bang i-email sa akin yung mga gawa ninyo? Or email na lang ba? Or paano ba? Wait, gagawa lang ako ng form. Okay, hello. Hello, everyone. Are we all back here? Refresh na ba? Okay, very good. All right, good, good. So I have updated the information regarding our Lions page for session 5. Okay, I had added K-means clustering. So that's going to be one of our topic actually the whole topic for this meeting. We will be talking about K-means clustering, not only in Python, but the whole perspective discussion with regards to K-means clustering. Okay. So are we all ready? Are we all settled in? Press 1, please, if you're... Paano ba ito i-zoom? Control plus. Ayan. Okay, thank you. Everyone is here. Almost everyone is here. So we will be talking about K-means clustering. Now, the reason why we are talking about K-means clustering, there are uh, we are pretty much done with the descriptive analytics. Now we are proceeding with the predictive analytics. So bear in mind that there are 4 essential analytics for data mining. So we are done with descriptive analytics. Mostly this is about exploring the data, describing the data, or providing visualization to the data that we have. Now we will be going to predictive analytics. So predictive analytics is the process of using historical data to make predictions about future events. It can be future events, it can be different kinds of future instances, but it's not most of the time events. Okay, it involves building models that can be used to predict future outcomes based off the past data. Predictive analytics is used to answer questions like what is likely to happen and what will happen if we take this action. Okay, so K-means clustering is part of the 2 components of predictive analytics. We have machine learning as our main protagonist, should I say, in predictive analytics. Machine learning is the buzzword when it comes to predictive analytics. And there are 2 types of machine learning. We have supervised learning and unsupervised learning. Let me type it on the chat. So we have supervised learning and we have unsupervised learning. So K-means clustering is a simple clustering technique. K-means clustering is a simple clustering technique which is under the unsupervised learning. So when we say unsupervised learning, this is a data set where we do not provide facts, only features. Maybe later you will understand when I say providing data without facts, only features. Okay. So now let's dive with the meaning of K-means clustering. So this is a clustering type which is unsupervised learning for unsupervised learning problems where we try to group similar data based on their underlying structure. So this is non-hierarchical. So meaning it is grouped based on their underlying structure but not based on hierarchical structures. Okay, there are different kinds of hierarchical or different kinds of clustering, and one of them is hierarchical clustering, which provides the like a family tree, parang ganon. Pero itong k-means clustering, it just clusters with an underlying structure. What is the reason by saying underlying structure? We don't know yet why they are grouped together, but they are grouped together by means of a mathematical function. Okay. By the way, learning machine learning doesn't require us to start with ample knowledge in mathematics. It does not require us mathematics at first. So the analogy of machine learning is like the parallelism is like when you want to drive a car. If you want to drive a car, of course, you will try to enroll for a driving school. In the driving school, you will learn there how to manipulate or how to drive the car. But if you want to advance your knowledge with regards to how the car works and how to optimize the car, that's the level or the second level of understanding how to manipulate cars. Just like in machine learning, if you are trying to talk about how to make this work, this is just like how to drive a car. You just need to learn how to drive the car or make it work. But if you are needing to optimize a certain task, that is where you need to learn more about mathematics. So the mathematics behind machine learning is linear algebra. You need to review your linear algebra. You need to review your probabilistic statistics, and then also calculus. So these three branches of mathematics are the fundamentals of machine learning if you are trying to optimize the algorithm. But if you just wanted it for it to work and you don't mind the optimization, you don't need to be an expert on those mathematical fields. Okay, so you're just like a programmer of machine learning, not yet a data scientist. So a data scientist is somewhat expert in those mathematical fields and also programming and the knowledge of data analysis. So some of us, when we start data science, some of us end up becoming data analysts. So the second level of data analysts are data scientists, because you can do both descriptive analytics and predictive analytics. All right, so there is an alternative higher level or alternative level of data scientists. We call them data engineers. But those data engineers have a different work with regards to data scientists and data analysts. The data engineers make it a point to establish the pipelines from raw data to the data warehouse. So that's the job of data engineers. That's why I call them alternative data jobs other than data scientists and data analysts. If you want to have also higher paying job, but you don't want to be more of like a mathematician, you can also pursue data engineering. Your main workflow will be data pipelines. So that's what data engineers do. Of course, your data, there are many sources of data, and most of the time data are coming from transactions, and alternative sources of data are from web scraping. Just like from my other work, I procure data from a certain company as a data web scraper. So I'm also a part-time data, somewhat a data. I cannot say that I am a data engineer, because in the company, there are two people working with the pipeline. So combining us both means we are working like a data engineer. Something like that. So that's also an interesting job. For me, it's just my side hustle, apart from becoming a full-time professor. So I'm somewhat like a data engineer to a certain company. So yeah, that's how I do sometimes. And that's a good side hustle. If you don't want to be a little bit, if you don't want to be fully stressed, because if you have two jobs, like you are a professor and then you are a data scientist, it will provide you ample amount of stress. So the pseudocode of the k-means clustering is actually getting the number of clusters, or the k, and then from those cluster we will choose centroids randomly. Centroids are like centers of a certain, like in this picture that you can see. It started to select a random centroid, and then eventually it will converge at the center, or the centroids will be updated. In time, it will be updated and try to make its way on the center, and it will provide, like, it will become like the leader of the group or the cluster. As you can see, every cluster has a designated color. Okay. All right. So they are optimized, or they are being computed with regards to a Euclidean distance operator. So the Euclidean distance operator is a distance measure. So the distance measure is actually square root of x sub I minus x, or j sub I plus us. Wala ako ditong formula, pero meron ba akong makikita sa internet? Distance formula. Okay, so this is the distance formula. So this is the distance formula. So the distance formula is a result of a point where it is equal to square root of qi minus pi raised to 2 or squared. So the many features you have, you need to compute for the distances of each points. Let's say, let's go back to this one. If you choose one centroid, that's P and Q, you're going to compare the distances of that centroid to each and every point or each of the existing point on the Cartesian plane. And once it tries to compute for the lowest distance value, it will assign itself as a neighbor or a group mate or part of the group. And then it will update the centroid. So there is a for loop which finds the nearest centroid and assign that point as the new cluster, or assign the point to that cluster. And then we compute for the new centroid. That's the reason why it's converging at the middle. Because at the middle, you can estimate all of the appropriate group mates on your cluster. Okay. So this is another flowchart, visualization flowchart, for you to easily understand the steps. So I want to compute that manually using Excel. So you get the intuition. I'm a zoom. I'm a zoom. Okay. Ayan siya, no? Basically, nasa na ulit yung ano formula. Where's that? Okay, so gawin natin tong formula to. You can follow with me. You can download the sample data.csv here. Can you see the data?
Yes. Yes.
Sabi ni Bianca, sir, it resembles the standard deviation formula. Is it related ba doon? Okay, so nakita na nila yung data. Alright. Nakita na ni Reggie. Ayan, parang same din sa algorithm ng gawa ng Hessian polygons. Probably might be the same, but hindi pa ako nakaka-encounter ng similarity nila sa standard deviation. Ang kino-compute ng standard deviation is yung sa ano eh, sa alpha. Doon ko lang nagagamit yun eh, sa alpha ng distribution sa statistics, sa distribution, to accept the, ano ba yung tawag doon? Kalimutan ko lang yung tawag. To accept the hypothesis alpha pag 0.5 Pearson correlation, tsaka yung isa pang term. Anyway, let's manually before we do the Python program, let's manually compute this one in Excel. Ayan. So we will do the distance formula. Let's say our selected centroids Just follow with me, no? Yun, hindi daw makita. Copy ito. Paste ko na lang dito. Ay, yung link. Ayan yung link. So, again, we will select first our centroids. We can say that this is K1 and K2. Okay. Di ko alam ba't ang lit na ito. Bakit? Ay, ito pala yung zoom niya nasa baba. Nakamak kasi ako ngayon eh. Sorry ah. Nakamak ako ngayon. So, yung K1 and K2 is sample number 1 and sample number 2. So, sample number 1, sample number 2. So, yun yung dalawang K natin. So, we will compute the distance formula of K1 and K2. So, I will type here equals square root of ayan sample 1, okay, minus sample 2, and then we will have squared plus, because it's is a summation, no? Is summation siya ng n. Ibig sabihin ng n is the features. We have given, teka, tapusin ko muna to. 72 minus, sorry, B2 pala to, no? At saka C2. Meaning the distance from itself. Itself muna. Then squared. Squared plus squared minus square root. Kulang pa. Ito. Teka. B2 squared plus C2 squared. Okay. Square root B2 squared. C2. Ayan. So ito yung, ba't hindi makita yung formula? Ayan yung formula. So given that our n is only 2. Our n is only 2. Bakit yung n natin dalawa lang? Kasi x and y lang siya. Hindi natin sasama tong sample number. Our n is 2. Our k is sample number 1. Ayan. So lagyan natin ng kulay. This is our k. Itong dalawa na to. Yan yung ating k. K means cluster. Yes. Bakit siya B2 minus B2 squared plus C2 minus C2 squared? Kasi yung K1 is kinukuha natin yung distance niya sa sample 1. Ang value ng K1 is parang siya, parang ganito siya. Yung 0.18572, kinukuha natin yung distance niya sa 185 by 72. Okay? And that results to 0, right? That results to 0. Equals to 0. Ito yon. Ito yung sagot na yon. Now, yung K1 is kukunin natin yung distance ng K1 sa point 2. Okay? Square root of B2, lagyan natin ng quantity, B2 minus C2 squared minus, plus C2 minus C3 squared. B2, 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 B2. Ayan. B2 squared C2, C3 squared. Square root of B2 minus B3. Ano ba yan? 21.93. So, ano nangyayari dito? So, this is K1 and this is 0.1. Okay. So, this is K1. K1 of 0.2. So, 185, 72, tapos 170, 56. So, this equals to 21.93. Right? Ayan yung lumabas. Oh. Tama? Nakukuha ba? We are getting the distance. We are getting the distance of K1 to 0.1 and K1 to 0.2. Now, our second centroid is K2. So that is 170 and 56. So kopyahin ko na lang yung formula sa taas, tas i-modify ko na lang. So this is starting with B2 minus B1. And sorry, B2. B2 and B3 muna pala. Ano ba yan? B3 and B2. Tapos ito naman ay C3 and C2. Oh, yan. 21.93. Okay. Okay. Question. May mga na ano ba? Nalilito ba? Nalilito ba? Three, four, five, 6. Update. Update centroid. Wala tayong i-update na centroid kasi we're talking about centroids getting the distance from the centroids. So hindi ma-update yung centroids. Now, itong point 3, the question is, itong point 3, centroid ba siya? By the way, nalilitan ba kayo or nalalakihan kayo sa ano natin? Nakikita niyo ba?
Yes, sir. Okay lang.
Kasi sa akin malaki eh. Sakto lang. So, lakihan ko na lang siya. Ayan. So, ang steps natin is first, step 1 is to get the centroid or to provide a centroid. Centroids. No? Usually, dalawa naman yan eh. So, dalawa yung provide nating centroid is 0.1 and 0.2. So yung K1 at saka yung K2, yung K1 is 0.1 and yung K2 is 0.2. That's why ito yung result ng mga distances nila. No? Therefore, ang assignment ng K1 is 1 or cluster 1. Cluster 1. Ang assignment ng K2 is cluster 2. There is no update of the centroid. Yan yung assignment nila. K1, K2. So now, dito na tayo sa point 3. So, ano mangyayari? This point, 185 and 72, which is K1, will have a distance formula with 168 and 60. No? So therefore, kukopihin ko na lang yung formula nito. Then, palitan natin siya. It's C2 minus C5 squared and then B2 minus B5 squared. So we need to get the distance formula of that. C2, C5, C2. Ay, nag-move
3
yung
po,
mga
sir.
numbers, sorry. So C3 na siya to C5 kasi nagdagdag ako ng cell. So C3, C5. So 20.81 ang distance ng K1 to 0.3. Ngayon, isa namang formula is yung distance ng K2 sa 0.3. So C4 na siya. C4 minus C5 squared. And B4 minus B5, 12. C5 and B5. Ayan. Okay. So dito, sa point 3, sino ang mas malapit sa point 3? K1 o K2? Siyempre, the lower the distance value. Lower the distance value,
K2.
that is winning cluster. So therefore, ang assignment natin will become cluster 2, 4.3. Okay? Cluster 4.3. And then we will update K2. since K2 is the winning centroid, we will update the centroid of K2 from the points of 0.3. Okay, so we will update that by getting 170 plus 168 over 2 169. Di pala kasya, no? Anyway, dito natin siya computin. 170 plus 68 divided by 2. So this is P, the new centroid. Yung sa distance formula natin. PQ, di ba? Ito yung Q. (56 plus 60 divided by 2. So the new centroids for K2 will become K2 to, sorry, K2. So the new centroids will become 169 to 86. 86. Yan na yung new centroid niya. Okay, tama. For K2. Ayan. Mahirapan lang tayo dyan mamaya. Ayan. Magbabago eh. Magbabago yung ano natin eh. So ngayon, ito naman, yung points natin dito sa 4, K1 and K2. So this is the new value of K2. Kulayan natin. Yan na yung value ng K2. Hindi na siya 170.56. Yan yung sinasabi ko kanina dito na nag-a-adjust. Hello? Hello? Nakukuha ba?
Yes, sir.
Nakukuha niyo ba bakit ko ni-recompute yung centroid? Kasi yung centroid is nag-a-adjust. Hinahanap niya yung pinakagitna. No? So mamaya, kukumputin din natin yung final centroid. So, yun yung reason kung bakit 6 lang yung points natin dito. Kasi gusto kong i-explain yung formula behind the k-means clustering eh. So, ibibigay ko din sa inyo tong file na to later. So, we have now, next is we will need to compute for the distance of K1 to 0.4. So, copy lang din natin to. Tapos i-adjust na lang natin. So, it's always starts with B. So, B3 and B, anong B yan? B6 na. B6. Tsaka C3, C6. Ayan. Then, yung bagong centroid dito ng K2. Nangyari lumabas. Kukopay natin eh. Ayan. So dito, hindi na siya B4. H13 na siya. H13 minus B6. B6. And then I13 to C6 squared. Ayan. Question. Sino, ano ang assignment ng cluster for K1? Very good. Ayan. Ngayon, since nag-assign tayo ng bagong class, kung na-assign natin sa K, kailangan natin i-recompute yung cluster 1. So yung cluster 1, i-recompute natin yung bago niyang K. Yung bago niyang K is 185 plus 179 divided by 2. Okay, so that's 182. Then 72 plus 68 divided by 2. Ayan, 70. Therefore, the new centroid is 182 and 70. So this is the new centroid of our cluster, our point, or sorry, our cluster. K2, Q, ito. Ayan. Yung C4, yan. Isulat ko na lang dito. Yes, kasi dapat nasa labas yung division. Sorry. Sorry for that. Ba't ba nasa loob yun? 58. Baka may problema tayo dito. Hindi, mag-auto-compute yan. Ayan, yan pa rin naman eh. Nag-auto-compute lang. So, 58 pala siya. So, hindi 86, 58. Sorry. Pero, ganun pa rin. K1 pa rin naman yung nanalo. So, yan. Nalabas natin yung ano. Ayan. Tama ba yung computation natin? Nasa labas yung 2. Okay, tama. Yan. So, yan yung bagong computation ng centroid natin. Okay. Then, ano pa? Solve naman natin yung 0.5. So, hindi na siya 185, no? 182 na siya. So, copy natin. So, ano na siya? 13, H14 na siya. H14 minus B7 and I14 minus D7 C7 ayan C7 ayan okay tapos HI14 and ay hindi H13 sorry H13 and B7 tama B7 and C7 I13 ayan tama ba results natin H13 ay ano nangyari sus H13 B7 at saka I13 C7 tapos 10 Ayan. So, sino ang nanalo na K? K1 again. So, K1. So, since K1 yung nanalo, we will update again K1. So, K1 again yung ma-update sa ating cluster. So, dito is yung 182 plus 182 7 divided by 2. Bakit natin ito minamanong compute? Kasi pag inano ko to sa Python, hindi na ninyo marirealize yung computation behind this. In short, pwede kayo mag k-means clustering sa Excel, kaso ganito nga mangyayari, manual. Kaya yun yung tulong ng Python sa atin. Hindi na tayo magmamanual, ino-automate na natin yung algorithm. Diba? Ito, yung minamanual natin yung algorithm minamanual computation natin yung algorithm. Para tayong nag-aano dito, linear regression. So yung bago na niyang so mga nagtatanong saan to nagagamit? Nagagamit to sa business case na, for example, ika-cluster natin yung yung meron kayong ang pinaka-easiest sample nito yung zoo dataset. Ina-cluster natin yung mga animals. Kasi may mga animals like for example yung hippopotamus. Yung hippopotamus is a mammal. Meron na siyang classification. Pero yung hippopotamus is aquatic. Ano pa? Yung dolphin, mammal din yung dolphin, pero using k-means clustering, makikita natin na part din siya ng mammal pero aquatic siya. At ang hippopotamus at ang dolphin ay magkamag-anak. Pareha sila ng ancestor. Ayan. So last na to, yung k-means clustering. Mamaya i-visualize natin to para mas ma-appreciate niya siya. Ito yung underlying computation ng Python natin. Meron tayong Python code nito basically. Mamaya pakita ko sa inyo pagkatapos natin. So yung last one is yung cluster 1. Ito. Okay natin. So hindi na siya H14, it's H15 na. And it's B8. B8. And I15, B8. C8. Ayan. Ba't ko na-edit yung isa? Ano ba yan? Okay, next is H13 pa rin minus C8 and H15 B8. B15 C8. So panalo pa rin si K1. Okay, K1 pa rin ang panalo and yung bagong centroids is plus 188 divided by 2 and then 180, 185, and 74. So, ito na yung bagong sa initial kung pwede po more than 2 yung initial clusters. Yes, pwede. More than 2 yung initial clusters, pwede naman. In this example, ginawa ko lang dalawa. Para lang hindi tumagal yung computation natin. Okay, so get the centroids. Next is step, i-summarize ko lang yung step na ginawa natin. Get the distance from the centroids to the points. Step 3, update the centroids and then step 4 until no more update with the centroid. Until no more update with the centroid, we will stop. So 70, ito na yung So pwede na natin itong i-plot. So i-plot natin siya, no? So kopyahin ko lang ito. Ito yung mga old points natin. Ayan. X and Y. Tapos yung final centroids natin, 169. Mamaya ko na siya ikakabit. Sorry. Mamaya ko na ikakabit yung 169 at saka yung 58. Gusto kong pakita muna sa inyo yung normal. Tapos 185. Uy. 185 to 74. 185, 74, no? So, i-graph ko lang to. Insert chart. Scatter chart. Ayan siya. Ayan. So, lagyan natin ng data. Data labels. Okay. So, big sabihin, asan yung initial centroid natin? Ang initial centroid natin is ito. Ito yung initial centroid natin. Gawa natin ng kulay. Fill. Pwede ba siyang solid line? Sorry. Bakit hindi makulayan? Kulay. Change color to yata. Change color to orange. Ito pala. So fill natin to... Ito yung initial Ito yung initial centroids natin. Tapos ito 170.56. Yan. So yan yung initial centroids natin, no? Tapos, anong nangyari? Nalagyan natin siya ng final centroids. Yung final centroids, yung 169, plus 58, and then 185 to 74. Na-compute natin yung final centroid. Pag sinama natin siya, ganyan. Ito siya, yung final centroid natin. 60, 58 ito. 58, 58 ba? 58, 56, and 72. 74. So ito na yung final centroid natin. Red na lang. Halos nagdikit yung ano, no? Yung mga data labels niya. Adjust ko lang. Ayan. So yung bagong centroid na, this one. So anong ibig sabihin niyan, ano? Kino-compute niya yung centroids nung ating scatter plot. Then nagpo-provide siya ngayon ng cluster. So basically yun yung cluster niya, no? Diba? Ayan yun. So orange, kaya ko siya orange. Hindi siya nagkakaroon ng line data. Wala. Anyway. So, yan siya, no? Yan yung basically nangyari sa kanya. And kung kukomputin ko yan sa Python, saan na ba yun? Ito yan sa Python, no? Ayan siya. Kinumpute natin siya sa Python. Basically, yung manual ko kanina is ito din siya. Although hindi ko na na-program yung centroid kung nasaan. Minagyan ko lang siya ng circle. So, anong ginagawa nito? Kina-cluster niya yung data points natin. Pino-provide niya ng cluster. Yung magkakasama, nilalagyan niya ng identification. Pinipredict niya yung cluster or yung belongingness ng data na yun kung saan siya. So yung mga business cases nito, tinanong ni Eileen May, yung 72 po yung original centroid, yes. I think so, yun yung ano, original na centroid. Yung orange, yung original centroids. Tapos, yung red, yun yung final centroids. Saan? Ayan. Yung orange, yung original centroid. Tapos, yung red, yung final centroids. Ay, sorry. Oo nga, no? Tama. 72. Itong 72 pala. Ayan. Ito pala yung blue. Iba pala yan. Ayan. Tapos, tama ba to? Nagduduling na ako. 169.58. 169.58. Okay. Tapos 170. Oh, 6. Ayan. 72. Oh, yeah. Yeah. Nagkamali lang ng konti. Ayan. Ayan. Yan. Thank you for that, Eileen. So yan yung cluster niya. Same with this one, no? Anong nagagawa niya? Napipredict niya yung cluster. Yan. Sa Python, ito yon. So, yung kagandahan ng Python, nako-compute natin siya using programs. Basically, ang computation na lang niya ito. Itong code lang na to. Yan lang yung computation niya. Kasi yung computation ni Python, meron na siyang formula para makuha yung centroid ng K1. K1. Ito. Basically, kukunin mo lang yung old point, yung original point, tapos i-divide mo siya, ipa-plus mo siya, tapos i-divide mo siya by 2 para mag-adjust siya. So, kaya ganun yung computation niya kasi dinidikit mo siya eh. Kaya ka nagdi-divide by 2, ina-average mo. Mini-min mo siya, min. Kaya siya tinawag na K-means clustering. 'Di ba? Ang ginagawa natin is averaging. Since dalawa lang yung K natin, edi over 2 siya lagi. So that's why it's called K-means. K meaning cluster minimization of the clusters using mean or averaging, kaya means. No. So may mga advanced computation pa niyan, pwede ninyong reviewin. Kunyari paano pag tatlo na yung clusters or 4 na yung clusters, ganun. Nag-iiba din yung computation ng mean. Okay? Anyway, so may ginagamit pa kaming isa pang tool which is, so pagka fast forward natin, ganito yung nangyayari, no, yung visualization na yan. Meron pa kaming ginagamit na tool which is what we call Weka. Ipapakita ko sa inyo ngayon. Ito yung mga ginagamit naming tool dati. May question ako, informative ba to sa inyo? Kamusta naman? Actually, ito yung mga kasama talaga na kailangan maintindihan sa data science. Kasi ang business case nito is groupings. Pwede mong i-grouping yung customers mo. Pwede mo silang using K-means clustering, i-grupo mo yung customers mo. Actually nga, next meeting, tatry natin gamitin yung K-means clustering in a real world dataset. So ngayon, basic muna yung dataset natin. Ang data science kasi talaga, kaya siya tinawag na data science, may mathematics talaga siya. Para tayong nag-aano dito, nagsa-science, di ba? Sa subject natin sa science, meron tayong chemistry, meron tayong physics. Pwede bang gamitin ito for segmentation? Pwede. Ano bang isa-segment mo? Anong naiisip mong segmentation? Jacqueline, customer segmentation. Pag may dataset ka ng mga different customers o kaya performance segmentation base sa performance. Pero gagawin natin yun sa susunod kasi unti-unti tayo eh. Hindi tayo pwedeng mag-jump doon hanggat hindi natin nagagrasp yung basic, yung pinaka-basic concept. So, next is yung weka nga. Ito ipapakita ko sa inyo. Yung weka na download to sa internet, itatype nyo lang sa Google weka. Pwede ninyong i-rewatch yung video at may mga tutorial naman sa internet how to use weka. No? So focus lang muna tayo sa weka. So this is weka na nada-download sa internet. Kailangan nyo lang ng Java dito kasi gawa to sa Java. Okay. So, Explorer. Okay, gamitin natin yung dataset natin kanina, which is yung simple clustering.csv. Ito yon, di ba? So ito yung ginamit natin data. Okay, nabilisan ba kayo doon? Hindi naman. Ulitin ko ba? Nag-zoom ba? Nag-zoom ba sa inyo or hindi? Sa akin lang nag-zoom.
Hindi ba yan?
Pwede, pero pwede nyo namang i-zoom yung... Kasi, teka, i-adjust ko yung display. Bakit sa display hindi siya masyadong maliit. Default. Dito, yung resolution nga gawin natin malaki. Ayan, gawin natin malaki. Lumaki ba? Hello? Lumaki ba sa part ninyo?
Yes,
Yun,
lumaki po.
Yes naman.
Lumaki po.
Hello?
Lumaki po.
Hindi ko kayo rinig? Oo nga, parang hindi ko kayo rinig.
Lumaki naman, bayan.
Pero,
Hello, sir.
Hello? Hello? Rinig niyo po kami, sir.
hello, hello?
Babe, rinig ka naman, bayan.
Teka, ayusin ko lang yung yung settings ko sa Hindi ko kayo rinig. Sorry. Hindi ko, kung nagsasalita kayo kanina pa, hindi ko kayo naririnig. Teka, where is that? Nagbakas ako ngayon eh. Teka, ayusin ko lang yung settings ko sa audio. Sa output. Sound output. Ang output ko is input ko is microphone. Hello, magsalita ka kayo. Try ko lang kung pipick up ko.
Testing.
Hello po.
Hello.
So far wala akong
Hello.
naririnig. Kung may nagsasalita man, wala. Hello, ito
Hello, hello, hello,
Hello, hello, hello, hello.
wala pa rin.
hello. Hello?
Ayan, maririnig
Hello
ko.
po.
Ayan
Hello,
na.
sir.
Naririnig mo na kami. Bayan.
Yes, yes.
Ayan. Yay.
Meron ba kayong question? Kaya gusto niya mag-mic?
Wala naman.
Wala. Nakikita niyo yung malaki na?
Hmm.
Okay, okay. So, ang ginawa ko dito basically, niload ko lang yung sample clustering.csv dito sa Weka. Don't worry, don't install this one. Papakita ko lang sa inyo. If you want to install this later and do it on your own, pwede, no? Papakita ko lang na dito is nakakapag-cluster din siya katulad sa Python. Ito yung ginagamit namin dati nung wala pang Python. So, gumagamit kami ng Weka. So, ang ginagawa ko lang is tinatanggal ko tong sample number kasi hindrance to sa computation later. So, sa ngayon, sama ko muna yung sample number. Since numerical to, masasama to sa computation. So, meron tayo dito sa taas, pre-process, which is yung pre-processing. Dito, pwede tayo mag-cleaning ng data natin. Which is, ito nga, pwede ko siyang i-remove. So, that's a simple cleaning. Then, may cluster dito. So, sa cluster, we will choose simple k-means. Ito yung pinag-aaralan natin. And then, kailangan naka-check lang yung store clusters for visualization. Now, I will just press start. Ayan, so na-predict niya na meron tayong, naka-set up pala ito ng dalawang clusters by the way. So, hindi ko siya nabago. Kung gusto niyo siyang gawing 3 or more than 2, just edit this out. Gawin niyo siyang 4, ganyan. So, magre-result siya sa 4 na clusters. Okay? Anyway, kung babalikan natin yung kanina, mali siya, no? 5 and 1. Kasi ayon sa computation natin kanina, ang result ng cluster natin ay sa dalawa, is tama naman dalawang clusters. Tama naman siya, di ba? Sa dalawang cluster siya. Okay? Center. Ayan. Dalawa siya. So kung ang nangyari kasi doon sa Weka is kung i-visualize natin, x-axis and y-axis. Yung blue, yun yung 5 nag-cluster. So parang itsura niyan, itong x dito sa baba, at saka x dito isa sa baba, tapos yung 3 sa taas, sila yung magkaka-cluster. So that is unacceptable kasi yung dalawang ito malayo siya dun sa 4. So bakit naging ganun? Bakit mali yung computation? Yun yung sinasabi ko kanina na sa pre-process, remove natin siya. Dapat yung dalawa lang na points, itong x and y natin. Now, punta tayo ulit sa cluster. And then, computein natin yung tamang cluster niya. So, simple k-means and dapat 2 clusters lang. Ayan. And then, press OK. Ayan, 2 clusters lang. Then, press OK. Then, we start. Press start button. Ito yung lalabas yung result. So, tama siya, no? 2 clusters is 2 and 4. Right-click, visualize lang natin. X and Y. So, tama siya. Itong dalawang nasa baba, ito yung first cluster and then yung second na 4 sa taas, ito yung second cluster. So tama siya. And then our Python, pagka krinos check natin, no? Pag krinos check natin, yung Python natin, ganun din yung result niya. Tama din. No? 4 sa taas and 2 sa baba. I believe itong Python nakapost to dun sa Leons natin. Ayan. So yan yung simple claimants cluster. So ang ginawa ko sa inyo is kinompute natin mano-mano yung pwede nating i-program sa Python. So basically ito yun. Ang initial problem is we want to know the clusters of our data. So in this example, very easy siya. Magkahiwalay talaga yung mga points. Pero may mga problems na sobrang hindi natin ma-identify yung clusters. Kaya natin i-apply yung clusters. Kung yari yung data umabot siya ng ng 10,000. So ang daming ang daming points diyan na lalabas. So i-identify natin yung clusters. So mga business cases ng clustering is customer analysis, sino yung mga potential na bumibili, pwede natin silang i-cluster. Naalala ko, ginagamit ko tong cluster before nung meron akong dataset na ang tawag namin doon is showroom dataset. Yung showroom dataset na yon, isa siyang survey ng mga taong pumapasok sa showroom. Tapos, yung mga tao na yon, yung iba bumibili, yung iba nagwi-window shopping, hindi naman talaga bumibili. Yung iba, pagka yung iba ang ginagawa, papasok, tas bibili na niya kagad yung gusto niya, hindi na siya mamimili. Okay, may mga customer na ganun, hindi na namimili dun sa showroom. Basta may alam na siyang bibilin na produkto, rerekta na siya dun, or he will go straight to that product and then buy that product. May mga ganung customer. So using the clustering algorithm, you can determine how many people are like that. Yung pupunta sa showroom, ang gagawin lang is mag-window shopping. Ayan. Yun lang yung gagawin niya. Malalaman mo kung ilan yung mga taong ganon using the clustering technique. Tapos malalaman mo ngayon yung ilan naman yung bumibili sa showroom mo using the clustering technique. Kasi pag yung data mo sobrang dami na, hindi mo na siya mamanu-manuhin eh. Kailangan mo na ng clustering algorithm para ma-provide sa'yo yung cluster or yung information kung ilan yung taong bumibili, ilan yung nag-window shopping, ilan yung yung ang ginagawa lang is yung iba yung may direkta na silang bibilin, hindi na sila magtititingin doon sa window, hindi na sila magwi-window or magse-select ng product. May bibili na agad sila, straight na agad silang bibili. Or yung iba naman, ang nangyayari is magtatanong sila ng mayroon talaga silang bibilhin, pero pag nakausap pa sila ng agent, may bibilin sila na above dun sa naisip nilang bilhin na. May mga ganun eh. Kunyari pupunta ako sa perfume shop. Ang gusto ko talagang bilhin is Polo Sport na pabango. Eh may nakausap ako na na agent, sales agent. Tapos sabi niya, "Sir, may mas mabango pa talaga kasi sa Polo Sport. Try niyo to, mas mura pa." May mga ganung customer din, nagbabago yung isip at the last moment. Pag basta may nakausap na So yun yung business case ng clustering algorithm. Mabibilang mo yun sa mga mga customers mo. Yun nga yung sinasabi ni Jacqueline na customer segmentation. Kasi madami yan eh. Ano pa yung mga, di ba kanina tinanong ko kayo ano yung mga usual na ginagawa nyo sa work? Yung dito sa Credit card? Ano, sino may credit card yung daw yung ginagawa? Ay, nawala na. Hindi ko na ma-scroll yung chat. Anyway, dun sa BPO dataset natin, pwede nating makluster sino yung mga tao na pare-parehas ng performance. Ayan, kay Eileen din pala yung credit card data for fraud analytics. Ngayon, sa credit card fraud analytics, pwede mong gawin dyan using clustering is meron different kinds ng frauds. Hindi mo pa alam kung ano yung mga different kinds of frauds sa credit card. Using the clustering algorithm, di ba, ginugroup niya yon. Malalaman mo ngayon doon yung pattern ng different kinds of frauds. Kasi yung mga different kinds of frauds na yan, meron niyang similarity sa isa't isa. Okay, tingnan natin tong dataset na to. For example, gamitin muna natin yung zoo dataset. So, yung zoo dataset, punta ako sa isang wait lang. Teka lang. Download lang ako ng zoo dataset. Ito kasi yung ginagamit ko na isang dataset for clustering. The zoo dataset. So, download natin to. Na-download ko na pala siya dati. Ay, meron na ako nito. Wait lang, kunin ko na lang dito sa akin. Ito. Meron na pala ako nito. Teka, stop share lang muna ako. Hindi ko ma-close yung mga Hindi ko ma-close yung mga Saan ba ako? Desktop. Ayan. So itong zoo dataset actually is nado-download naman yun sa online. Pero pwede ko naman yan i-post doon sa sa Leons natin. So close ko to. Tapos sumaware ka. Explorer. Ito yung bagong Explorer natin. So i-load ko lang yung zoo dataset. Open file. Hanapin ko lang siya. I believe nasa downloads ko yun nilagay. Tapos CSV file siya. Ayan, ito yung zoo dataset. Okay. May problema ng konti doon. Edit ko lang ng konti. Open with Excel. Kapag ano ko naman, pre-22, expected 19. Line 2 problem. Line 2. Line 2. Bakit magpa-error siya? Some features are sure will accommodate and service features save with Excel file format. Sige, save ko na lang as file formats. Excel. CSV UTF-8 pala dapat. Okay, sige, check natin. Ano pala? Tama naman siya. Actually, tama naman siya sa akin. Ayun, no? Wala naman mali. Okay. Bakit ganun? Ay, sorry ito. Papalitan ko pala. I-remove ko pala itong clusters. Ayan. Ayun, yung describe. Yan pala eh. Save. Ayan, okay na yan. Gagana na yan. Ayun. So, nalagay na natin yung zoo dataset dito sa ano natin. Basically, gagawin ko lang dito is kailangan natin yung different kinds of animals na to, meron siyang, I think, sabi dito, meron siyang 7 types. So yung 7 types na yun, I think they are mammals, fishes, birds, no? Mammals, fish, birds, insects, crustaceans, amphibians, reptiles, ganun ano, so different kinds of animals. So, ika-cluster natin siya. Although, para na siyang naka-cluster. Para siyang naka-cluster na different types nga, di ba? Merong reptiles, merong mammals, pero may mga animals na overlapping. Yung sinabi ko kanina, yung mga, let's say, hippopotamus, at saka yung mga dolphin. So, tingnan natin yun. So, pipili natin yung simple k-means clustering. Tapos, I think dito, in this problem, let me use the cluster 5. Alam natin na 7 yung kinds ng animal dito. So, technically, normally 7 natin siya ika-cluster. Pero, that's not the case. Even if they are 7 kinds of animals here, we can cluster them to 5 just to understand sino yung magkakasama. Even if they have the different type of an animal. Okay? So, pinili ko na yung 5 clusters. And then, start natin siya. Ayan. So, meron tayong 41 animals sa zero cluster, meron tayong 17 animals sa cluster 1, sa cluster 2, 21 animals, sa cluster 3, meron tayong 14 animals. And then, meron tayong 8 clusters sa sa cluster 4. So, i-visualize natin siya. Yan. So, piliin natin dito yung type at saka cluster. Ayan. Kung mapapansin nyo, meron tayong 1, 2, 3, 4, 5 clusters. Meron tayong yung kulay ba kita? Ito. Yan. Kita nyo na?
Yes po.
Yan yung mga clusters niya. No? Yan yung mga clusters niya. Yan. So, kumpulan dito yung cluster 0. Tingnan natin ngayon. I-save natin yung result nito. So, this is the zoo.data.result.arff files. Tingin ko nasa desktop yun. Nasa desktop kaya nasa download siguro. Saan ito? Dito pala na save. Hindi sa desktop. Ulit, save ko na lang sa desktop. Dito. Save. So, ang result niya can be viewed by a text editor. Ito yung result niya ngayon. Ayan. Copy-paste ko na lang siya sa CSV file para mas madalian tayong mag-analyze ng cluster. Kung mapapansin ninyo, nagkaroon siya ngayon ng cluster. Ayan. Oops. Tanggalin ko lang itong describe. Blah, blah, blah. So, ito yung results ng ating cluster. Okay. Para kailangan natin ng filter. I-filter ko lang para ma-analyze natin. Filter ko siya. So, piliin lang natin yung zero clusters. Ayan. So, this is the zero cluster. Pag-aralan natin yung zero clusters. Fins, legs, tails, tail, domestic, cat size type, cluster. Yung cluster 0, sa tingin ko puro siya mammals. Aardvark, yung aardvark parang ano yan, man-eater, ant-eater. Alam niyo ba yan, yung anteater? Yan. So yung aardvark para siyang anteater, antelope para siyang deer or deer animal siya. Bear, boar. Kung mapapansin niyo lahat may hair. Pupera dito sa isa. Sino yung animal na walang hair? Hello? Hello, hello?
Hello po. Yes,
Sino yung
dolphin.
animal na walang hair?
Dolphin.
Dolphin. Yung dolphin kasi, isa siyang type of mammal. Ayan, type of mammal siya. Pero siya rin ay isang aquatic. So, ang pwede nating sabihin dito, bakit nasama yung dolphin sa cluster 0? Kasi ang dolphin, meron siyang milk. So basta may milk, nasasama siya dito. Even though na aquatic ang dolphin. Or in short, mammal siya. Kasi lahat ng mammal nagpo-produce ng milk. Okay? Ayan. So yan yung gusto natin makita sa cluster. Kahit na ano siya, kahit na dito aquatic siya or nakatira siya sa tubig, pwede pa rin natin siyang makluster as mammals. Yun ang ibig sabihin ng cluster 0. Puro siya mammals. Irregardless of cluster. So, kaya napunta dyan yung dolphin kasi ang dolphin meron din siyang backbone at originally ang dolphin oxygen ang kailangan niya. Oxygen. Although hindi walang legs ang dolphin, no? So nangingibabaw pa rin ng kanyang pagkamamal. Kaya because of clustering, nagbibigay siya ng drill down knowledge na even aquatic ka, you are considered a mammal. Tingnan natin yung cluster 1. Tingnan natin yung purity ng cluster 1. Octopus, slug, worm, gnat, flea. Tingnan natin yung kanyang muna. So meron siyang mga type 7. Ano yung mga type 7? Mga fish style. Clam, crab, crayfish. Tapos meron siyang type 6 which is mga insects, I think. Housefly, honeybee, gnat, flea, insects, ladybird. So is fish at mga insects. Ano ang common denominator nila? They lay eggs. So itong mga cluster pala na 2, makikita niyo yung pattern ngayon kung bakit sila pinagsama-sama. Even if they are fish and they are insects, they all lay eggs. And they don't have a tooth. Wala silang tooth. Wala silang ngipin. Wala rin silang backbone. So yun yung mga common traits nila. No? Ano to? Pwedeng domesticated. Honeybee. Honeybee pala pwedeng i-domesticate. Ayan yung cluster 1. So, ibig sabihin pala, yung clustering, pwede natin i-cluster sila based on pattern. Hindi lang dun sa katangian ng kung ano sila, kung fish ba sila or they are insects. Itong 2, cluster 2. So puro sila bird. No, pero may tortoise. Oh, di ba? Interesting 'yon. Bakit na-cluster ang tortoise sa mga birds? So wala siyang Ano yun? Wala siyang feather, di ba? But they lay, same sila, nagle-lay sila ng eggs. Dito niyo makikita sa clustering yung ano yung mga possible ancestry, no? Possible ancestry ng ibon at saka ng reptile. Kasi di ba parang reptile na rin ang mga tortoise. Oh, pero di ba, ano siya? O tingnan nyo. Two is bird. Probably 3 is reptiles. No, yung tortoise. Tama ba? Ang tortoise ba ay reptile? Ano pa yung commonality? May backbone sila at they are all breeding. Or possibly kasi pag breeds, ano sila? Territarian. Or nasa ano sa lupa sila. So, may pagka-bird ang tortoise. Diba? Very interesting ang clustering. Ano pa? Number 3 clusters. Dito, they are all fish. They are all fish. Pero may isa palang insect. Ay, di. Isang reptile, si snake. Yun. So, may isang reptile na fish. So, ang fish, napapansin ninyo, yung ibang reptile, kamag-anak ng fish. Kasi may scales ang fish, may scales din ang reptile. At ang ibon, kamag-anak din ng mga reptile kasi yung feathers ng mga ibon, yan yung mga dating scales ng mga reptiles. Nag-evolve lang kaya nagkaroon ng ibon. And then cluster 4. Anong katangian ng mga cluster 4? They are like amphibians but kasama rin sila ng mga reptiles. So yung amphibians yung 5, no? Frog, newt. Anong commonality nila? They are laying eggs. Hindi naman venomous. They are all terrestrial predators. Airborne, hindi sila airborne, hindi sila milk, hindi silang feather. Kadalasan they are predators. Pero itong cluster 4, ang pinaka-commonality lang nila is breeds. No? Pwede din yung negative, yun yung commonality nila. Wala silang feathers, wala silang milk, wala silang hair. Pwede yung 0 din yung reason ng commonality nila. Pareha silang walang ganon, kaya sila pinagka-cluster. Wala silang fins, hindi sila domesticated, hindi sila pwedeng i-domesticate yan. And they are not cat size. So they are cluster 4. So based doon sa mga ano natin, features natin na to, pwede natin ma-analyze yung cluster na yun. Okay? So let's time check. It's 12:47. Malapit na tayo matapos. So let's do that for question and answer na lang muna. Okay. So ilalagay ko yun doon. So ang nagawa nito is na-provide niya yung cluster. Yun yung ginagawa ng K-means cluster. Nalalagyan niya ng new column na cluster. No? Ngayon pwede natin siyang i-visualize based on cluster. Ayan. So susunod, try natin i-cluster yung BPO dataset. Yan, pwede natin yan i-cluster. I think. May i-clean lang tayo ng konti at maka-cluster na natin yan. Meron ba kayong katanungan? Questions? So dito ko dagdag yung mga datasets. So pwede ninyong paglaruan your datasets. Saan ba yun? So dataset. Nga pala yung iba, no? Join kayo sa Slack para mas updated kayo sa announcements. Kasi kung dito lang kayo magre-rely sa Lions, ma-delay kayo sa saan ba yung datasets dito? Siguro. Yeah. Ayan, any questions by the way? Any questions? May question pa ba? We will do more of clustering next meeting. Then session that will be session 6. And then I will introduce then sa session 6 yung isa pang machine learning style which is supervised learning. So possibly ano yun, naive based approach or probability algorithm yun. Wala na ba tayong questions? Kung wala na tayong questions, sa Slack, pwede nyo akong tanungin doon. Then, as much as possible, magre-reply ako. And then, yung recording nito baka tomorrow pa ma-upload. So, thank you very much for today's session. I hope you've learned something that you can do after this lesson. Pwede nyo pang pag-aralan pa. Ayan.
Sir,
Ano yan? Question ba? Hello? Sige. Okay, thank you. Thank you. I hope you learned something new today. Thank you very much. See you next meeting.